It's a mega plane, bigger and heavier than any other passenger plane in the sky. It will hold more people than any commercial jet flying. Designers have spent billions. Now is the moment of truth. Will the world's biggest passenger airliner survive its maiden flight? An early spring morning, clear skies and a light breeze over southwestern France. Crowding the fields that flank Toulouse International Airport, 40,000 spectators, backpackers, campers and journalists from around the world. All vying for the perfect spot to watch the maiden flight of the Airbus A380, the largest passenger plane ever built. It's 73 meters long, 7 stories tall at the tail, almost 80 meters from wingtip to wingtip. Heavier, longer and taller than a 747, with 2 full levels of seating, enough to hold over 550 passengers. Getting this monster off the drawing board required new, super lightweight materials, 4 powerful new mega-sized engines, massive new factories across Europe, and a computerized flight control system more sophisticated than any other in commercial aviation. This moment is the biggest gamble that the company has ever taken. A $12 billion investment, the company's entire future, and the lives of future passengers all ride on the success of this historic test flight. Alongside the runway, a hush settles over the crowd as the megaplane comes into view. Gradually, it gathers speed, accelerating to reach its takeoff velocity of 269 kilometers per hour. Then, as it nears the end of the runway, the moment of truth. The massive nose tilts skyward. A sliver of daylight appears beneath the rear wheels, and the Airbus A380 takes to the sky for the very first time. The engineers and technicians in the crowd breathe a collective sigh of relief. Their baby is flying. The question now is, does anyone want a plane this big? Will the unprecedented size prove a boon or a boondoggle? Is this super jumbo the future of commercial aviation? Or the biggest white elephant since Howard Hughes built the Spruce Goose? It all depends on whether Airbus can convince airlines that travelers will want to trust their fates to this flying cruise ship. No one yet knows the end of this story. But one thing is sure, any failure on this day, even a minor setback at this critical moment, would be a crushing and very public disaster for Airbus, with consequences that would reverberate around the world. The plane disappears from view. For the next 4 hours, while the flight crew puts this massive cruiser through its paces, the gathered crowd has little to do but wait, and perhaps reflect on the journey that brought them to this moment. The historic journey that began almost 40 years ago. 1969 was a year of technology firsts. That year saw the arrival of 2 exotic new airliners. Boeing rolled out the 747, the first double-decker passenger plane, larger and heavier than any other. Powered by 4 Pratt & Whitney JT9D engines, providing a total of 186,000 pounds of thrust, the plane had enough oomph to carry more than 400 passengers and their baggage, more than double the capacity of the 707. The plane wasn't an immediate hit, But eventually, it took off.
The Concorde is here.
That same year, Aerospatiale and British Aircraft Corporation, the precursor to Airbus, introduced the Concorde. While Boeing was bulking up, Europeans were getting small, but very fast. The Concorde traded capacity for speed. The plane carried only 128 passengers, but it could cruise at twice the speed of sound, cutting the trip from New York to London from almost 8 hours to just under 3.5. Both the 747 and the Concorde came to be the epitome of luxury in air travel. These two differing visions came to symbolize a fierce rivalry between American and European aerospace giants. A rivalry that's only intensified with time, even as the business of air travel has changed dramatically. The Concorde, after years of financial difficulties and a devastating crash in Paris, has been grounded. And the 747 is now an aging workhorse, noted less for style and more for the sheer number of passengers it can pack between its wings. What changed to turn air travel from a luxury to the airborne bus ride that it is today? Simple economics. In just a few short decades, the number of people traveling by air has tripled. Now, every day, hundreds of thousands of people pack into 70,000 flights, taking off and landing at more than 4,000 airports around the world. And those numbers are only going to get bigger, much bigger. Industry analysts predict that the number of air travelers could double again by the year 2020. That is, if anyone can figure out how to squeeze them into an already overcrowded system. Both Boeing and Airbus saw the writing on the wall in the 1990s. But the companies each took a very different bead on the problem. Boeing believed that one of the biggest increases in air travel would be point-to-point flights. Get on near your home, get off near your destination. Boeing put its muscle behind the 787 Dreamliner, a highly efficient plane designed to carry an average of only 250 people. The A380, though, is an altogether different order of beast. It's designed for hub-to-hub travel. Passengers will board a small plane near their home, then connect at a major airport to a larger plane, travel halfway around the world, and get off at their final destination. It's a strategy specifically designed to serve the most rapidly expanding long-haul routes in and out of Asia, and to cater to customers who appreciate a bit of pampering. The plane's sheer size, with 2 passenger decks, is large enough for both standard seating as well as more luxurious features, like a lounge, a high-end shop, 2 staircases, even a waterfall. It's a breathtaking dream. But no one knew if such a plane could be built. Some argued that such a craft would be far too heavy and expensive to be practical. But a tenacious and aptly named Airbus executive, Charles Champion, wouldn't take no for an answer. He encouraged his design team to think outside the box.
Yeah, well, there were lots of weird designs. Some looked at the double bubble.
One of their first ideas, the double bubble, a double-wide fuselage. It looked promising, but computer analysis showed that it would be far too heavy and not sufficiently aerodynamic. So Champion sent his team back to the drawing board, and eventually they came up with this history-making concept. A full-length, double-decker passenger cabin, with a third deck below for cargo. Space-wise, it's the equivalent of 2 complete wide-body cabins, one on top of the other. The new plan called for an aircraft only 2.5 meters longer than Boeing's 747. It was 15 meters wider and 5 meters taller. But when they ran the design figures through the computer, they had a shock. The plane was far too heavy.
we came up with horrid figures, saying, my God, this is the weight of the aircraft, doesn't work. And we came up with horrid figures, saying, my God, this is the weight of the aircraft, doesn't work. So what we did immediately at the launch of the program, or 2-3 months afterwards, we launched a very strong challenge on the weight.
The team set out to bring the base weight of the aircraft below 277 tons. That's only about 50% heavier than the 747. An ambitious goal for a plane designed to carry over 100 more passengers and their luggage halfway around the world. Unless Champion and his engineers could find the means to beat that target, the dream would die. Airbus engineers were faced with a design challenge that called for a lightweight plane carrying over 550 passengers at a lower cost per seat, not to mention quieter and less polluting than anything in the air. The design team knew they would have to rethink everything. They needed lighter materials, more powerful engines, larger wings, even bigger and smarter factories. Every component would have to be scaled up from supersize to mega size. But even while the engineers were still scratching their heads over the details, the Airbus sales force was already hard at work, seducing customers with visions of the future. They created a full-sized interior mock-up that promised passengers in coach some relief from the grind of travel. With seats an inch wider than in other planes, and overhead bins 10% larger. Each plane can also feature a new interior illumination scheme to eliminate the upsetting effect created when flight attendants suddenly switch on overhead lights. The kinder, gentler system in the A380 mimics the gradual transition from day to night and back to daytime again. These and other innovations make the plane distinctive, but it's the promise of opulent luxury that really turns heads. To help build excitement, computer programmers constructed a virtual showroom where airlines can bring to life their wildest design fantasies.
Ladies and gentlemen, this is your captain speaking. I'd like to welcome you on board this 3D tutorial for the A380 main deck door.
Using this 3D lab in cyberspace, airlines can experiment with cabin layouts, color schemes and seating arrangements. Airbus has encouraged customers to think big. Bathrooms with showers, spacious lounge areas, restaurant bars, and even an in-flight salon. But until the planes are actually put into service, most airlines have chosen to keep their final designs as closely guarded as any other trade secret. But one early enthusiast, Richard Branson, maverick founder of Virgin Atlantic Airlines, couldn't restrain himself. He announced plans for a deluxe version of the A380, featuring a casino and double beds on the upper deck. At a press conference, he famously quipped, "So alongside our casinos, you'll have at least 2 ways to get lucky on our flights." Of course, no dream could take flight until engineers came up with a way to lift all that weight. In late 2000, builders finally settled on a design. For power, they would buy engines built by Rolls-Royce, capable of providing 30% more thrust than the engines used on the 747. Each massive power plant cost $15 million, as much as a ton of gold. Altogether, they account for almost 25% of the cost of the entire plane. But if there's one thing this aircraft needs, it's thrust that won't quit. Each engine provides up to 80,000 pounds of force. Running at top speed, this mega guzzler sucks down a litre of gasoline every second. The A380 is designed for routine flights lasting 13 hours or more. That means when it's fully tanked for takeoff, the A380 carries a lot of fuel. 260,000 litres, 20% more than the load carried by the 747. Just imagine what would happen if anything threatened the integrity of one of those fuel tanks, like a catastrophic engine failure that sends shards of metal tearing through them. That's the nightmare that haunts engineers at Rolls-Royce, and they're about to destroy an engine to make sure it never occurs. These 24 titanium fan blades suck air into the maw of this A380 engine. Each blade is 1 meter in length and weighs 15 kilograms. Lightweight, but super strong. When the engine is roaring along at full throttle, the blades spin at almost 3,000 revolutions per minute. The centrifugal force at the tip of each blade is equivalent to the weight of a 110-ton locomotive. If one of these were to break off and escape into the engine, it could wreak unimaginable destruction to the plane. That's why Rolls-Royce engineers are about to conduct an engine failure test. They're going to intentionally cause one of the fan blades to break off at full speed in order to prove that the engine enclosure can contain the damage without letting any metallic fragments escape. In the process, they will totally trash this $15 million engineering marvel, a small price to pay when the lives of over 550 people could be at stake. A super slow-motion camera captures every moment in excruciating detail. The blades are striped to make visual measurement easier. When the fan is spinning at full speed, engineers send a signal to explosive bolts at the base of the multicolored test blade. Faster than even this camera can see, the knife-like piece of metal shears off and flies into the engine mechanism, wreaking havoc, but no fragments escape. The A380 engines are safe for flight, but there are many more pieces to the puzzle. Every other major component would have to be designed from the ground up. Luckily, Airbus has already turned the world into a giant mega factory. With 1,500 suppliers and facilities used to build its existing planes, scattered over 30 countries, yet tightly linked by an advanced communication and transportation network. To assemble the hundreds of A380s the company hopes to sell in the coming decades, planners settled on 5 countries to build the major components. Wings in Wales, engines in England, the fuselage and vertical tail section in Germany, the horizontal tail section in Spain, and of course France, where all the pieces came together to assemble the finished plane. The process begins in Wales, in 2 huge new wing factories, built to assemble the largest and most structurally complex commercial airplane wings ever designed. 32,000 components, shipped in from every continent except Antarctica. The wings on the A380 are true mechanical marvels. They provide flight control and enough lift to carry the fuselage, plus the 4 supercharged engines, each weighing nearly 6.5 tons. And with 260,000 litres of fuel loaded inside 10 interior locations, the wings are also flying fuel tanks. They're one of the most critical structural components in the entire aircraft. The precision construction process begins with sheets of aluminium. Destined to be shaped into the 10 panels that cover each wing, each piece has its own shape and weight requirements. To whip one up, just follow 3 not-so-easy steps. Shave it, wrap it, then bake it. This 34-meter-long slab of aluminium weighs in at 5 tons. Way too heavy for the wing panel it's destined to become. In its final form, it will weigh close to 1 ton. So off it goes, to get the aerospace version of a tummy tuck. Overhead cranes use 32 powerful suction nozzles to lift and transport each aluminium slab. Tim Fernifer carries the burden of responsibility. Using a remote-controlled steering device, Tim guides the 5-ton piece of metal across the factory floor, but he can't do it alone. His team must watch the motion of the wing panel throughout the ride.
You've got to be particularly careful that I'm handling it. I can't see down the other end, so I need another pair of eyes down the other end. It's just health and safety issues. You have to watch, make sure everybody's out of the way when it's actually moving.
It's a dicey ride across the factory floor before the huge sheet can settle safely into position. A milling machine 40 meters long. Like an oversized cheese grater, the precision cutting head slowly cuts back and forth across the surface of the wing, painstakingly shaving the aluminium until the panel shape matches the 3D contour map stored in the machine's computer. The process takes up to 3 days. It eliminates 75% of the panel's weight while maintaining its strength. Then it's ready for the oven, one of the world's largest pressurized heat chambers, 42 meters long, almost 6 meters wide. Technician John Massey has cooked plenty of wings for smaller Airbus planes, like the A320.
It's a challenge to see it go from the size of the 320 to the size of the 380. It's a huge, huge jump.
The A380 wings are 50% larger than A320 wings. That means a 50% greater chance of error in this critical process. Baking requires careful setup. First, Massey and others place the segment in a special metallic form. Then they vacuum seal the entire assembly with a massive piece of plastic shrink wrap to protect the metal from contamination. Inside, the heat must be uniform across the entire panel, 150 degrees centigrade, with no room for error.
We try to avoid any changes in the vacuum or the temperature, so the temperature must remain constant right throughout the process. It must maintain within 3 degrees, otherwise the run is invalidated.
After 24 hours, the panel is ready. Specially equipped vehicles rise up and move into place in front of the oven. All eyes are on the plastic protecting the wing panel. If it breaks, the aluminium wing piece is compromised. A disaster. The entire wing panel would be worthless.
If the bag bursts, it means starting the job again from scratch.
Anxiously, they scan the surface for any breach. At last, the wing is cool enough to touch. And good news, the bag appears to be intact. Finally, the wing segment arrives in its docking bay. Here, the technicians first remove the plastic and cloth wrap. Now begins the tedious search for flaws. John's boss, Gareth Williams, arrives to inspect the piece. He retrieves small metal rods that were baked onto the top of the wing panel. Each of these cylinders tells an important story about future safety.
These are test pieces which are made of the same material as the wing panel, and we use them to confirm that the heat process that this part's just gone through is correct and it's to the right specification.
When this testing phase is complete, Gareth and John get the okay to move the wing to its next destination. The nearby wing assembly plant, an enormous brand new factory located just up the road. It's one of Britain's largest industrial buildings built in this century. It's nearly 85,000 square meters in area, equal to 12 full-size football pitches. This is where the builders attach the aluminium skin panels to the wing skeleton. George Lee guides his team through the tricky assembly process. Today they're preparing to lift and place one of the largest of the 20 aluminium panels, 34 meters long and weighing in at more than 1 ton.
Size is a great challenge because everything requires some form of overhead lifting. Nothing can be lifted manually, so virtually everything requires overhead craneage movement, and therefore the management of the craneage system is very, very important.
The panel hangs like a huge guillotine, suspended over the factory floor. But that's not all that's hanging over the assembly team's head. Time is running out. Along the edges of the partially constructed wing, builders have applied a sealant that will help to ensure the integrity of the fuel tanks. The sealant dries quickly within hours. The team must fit the wing panel into place before the sealant dries, or the wing could be defective. This time they're cutting it close.
The only concern I've got is the time factor.
If they don't succeed, the team will have to scour the sealant off the aluminium surface and start the whole process again. Finally, the panel settles into place. 1 down, 9 to go.
It can be stressful, yeah, it can be stressful. At this certain times, it's an enjoyable job, because when it actually all works and goes together, it's quite enjoyable. You've made it an achievement.
Now it's time to glue and bolt together the pieces, like building the world's biggest model airplane wing. This part of the process remains a carefully guarded trade secret. The company wants our cameras off.
No cameras.
The secret assembly process inside the jig will take nearly 4 weeks to complete, but it takes more than a wing to make a plane. All across Europe, more factories are coming online, pumping out body parts of this giant Franken plane. But not everyone is happy to see this kind of progress. Some locals in Germany are up in arms over Airbus's ambitious plans. This is the newest Airbus factory in Hamburg, a megastructure big enough to house 4 A380s side by side. Airbus has been building airplane fuselages in Germany for more than 30 years. But with the announcement of the A380, the company needed to massively expand the site and send finished planes here to get tricked out on the inside and painted on the outside. No matter what the customer wants their plane to be, a 550-seat cattle car, a high-class hotel in the sky, or even a heavy-duty freighter, this is where the seats, the carpets, the stairs, and yes, even the bar and the waterfall will all be installed. The expansion plan called for 3 new buildings and a longer runway to accommodate the massive plane, but there was a problem. Airbus's main factory here sits alongside Germany's Elbe River, smack in the middle of Europe's largest tidal wetlands.
It's a very special area because we have there the influence of water from the country and tidal water from the sea. So we have a mixture of sweet water and salt water.
This fragile ecosystem is home to 70 species of migratory birds. Now 71 if you count the Airbus A380. Airbus wanted to fill in 140 hectares of pristine wetland, and local activists cried foul. A pitched battle in the courts and demonstrations in the streets delayed construction of the factories for over 2 years. But eventually, local and national politicians who wanted to bring business to the community intervened. The factories went up. One got busy building fuselage segments, but the other 2 stand nearly empty. More lawsuits still block the Hamburg facility from taking delivery of all of the planes it's meant to finish. Unless the company wins in court, it may have spent a few $100 million building a factory of little use. The problem lies with the runway. Airbus needs a longer runway to accommodate a heavy-duty cargo version of the A380.
We need the runway extension in Hamburg for the pilot to test the performance of the aircraft. And he only can test this when he has an aircraft with a weight which is approximately the weight you normally have in cruise altitude and a normal scheduled flight.
That plan to lengthen Hamburg's existing runway has met with considerable resistance from locals. Their concern: extending the runway will bring the tarmac to within just 450 meters of village orchards, and uncomfortably close to a Lutheran church that houses a priceless organ built in 1688. A delicate instrument that could be damaged by ground vibrations and wake vortices, turbulent bands of air similar to miniature tornadoes.
We have very precise information on is the generation of these wake vortices, so small, let's say, tornadoes, wind generated by every aircraft, more or less, which can affect buildings and also persons close to the runway or close to the flight path. And we have predictions that we should expect occasionally winds up to Beaufort 12, which is about 130 kilometers per hour in the core, and these tornadoes will hit the church tower and the roof construction.
Villagers may have reason to be concerned. For years, they've tolerated another big plane in Airbus's fleet, the Beluga, and uncomfortably close to a Lutheran church that houses a priceless organ built in 1688. A delicate instrument that could be damaged by ground vibrations and wake vortices, turbulent bands of air similar to miniature tornadoes.
We have very precise information on is the generation of these wake vortices, so small, let's say, tornadoes, wind generated by every aircraft, more or less, which can affect buildings and also persons close to the runway or close to the flight path. And we have predictions that we should expect occasionally winds up to Beaufort 12, which is about 130 kilometers per hour in the core, and these tornadoes will hit the church tower and the roof construction.
Villagers may have reason to be concerned. For years, they've tolerated another big plane in Airbus's fleet, the Beluga, a custom-built freighter named for the white whale it resembles. The Beluga, smaller than the A380, was custom-built in 1996 to carry pieces of Airbus planes to and from various factories. Village people and builders have already felt the shaking caused by the Beluga, which may get worse when the much larger A380 comes to town. Airbus contends that fears are overblown, but if the protesters win, Airbus may have no choice but to pull up stakes and build the freighter factory and runway somewhere else. Which group will come out on top? The local villagers or the corporate giant? The lawsuits are still working their way through the courts. Legal action by angry locals is one risk the company is vulnerable to. But just 57 kilometers away in the town of Stade, another big gamble is underway. The company is using a futuristic material to build the largest commercial aviation tail fin in the world. It's called carbon fiber reinforced plastic, and it's made out of the same stuff that gives diamonds their incredible strength. Carbon fiber is 6 times stiffer than steel and much lighter. It's the only option if builders are going to keep the weight of the plane below the target of 277 tons. Unlike forged metal, carbon-reinforced plastic parts are actually woven, like cloth. Fabricating machines spin out tail panels by combining super-strong carbon fibers with plastic resin to create almost any shape the designers can imagine. After baking, strengthening, painting and drying, technicians join the lightweight panels to the tail skeleton with the help of this computer-controlled riveting robot. Working around the clock for a week, the robot makes 10,000 critical connections with intolerances no human can match. The integrity of the tail fin is crucial to the safety of passengers. Airbus engineers know only too well what can happen if a tail structure fails. In 2001, American Airlines Flight 587 left JFK Airport in New York. Less than 3 minutes later, the Airbus A300 aircraft had crashed in Rockaway, a neighborhood in Queens, New York.
Very full. The pitch then left side and make it straight all the way down.
It was the second deadliest crash in US history, and investigators made a disturbing discovery. It had been caused when the tail fin and rudder, made partly out of composite materials, sheared off as the plane accelerated. Investigators concluded that cockpit errors, not a failure of the carbon composite material, most likely caused the crash. And builders have applied the lessons of that catastrophe to the tail fin of the A380. But today, something's gone wrong on the factory floor. A lightning strike zapped the power supply, and now the precision riveting robot is dead in the water.
We had a storm, a lightning strike. The PC failed and the hard disk was completely gone.
Mother Nature has thrown a wrench into the works. causing a total crash of the system.
It is electricity. Sometimes it happens. Normally we are protected, but it can just happen.
Critical hours pass as Kai Baumgartner and his colleagues struggle to get the robot back online. If they can't fix the computer, they can't make the deadline set for finishing this tail fin. Kai and his team must find the problem, and quickly. By the end of the shift, the sound of riveting echoes through the factory once again. Kai is finally back at work, personally verifying that every one of the 10,000 connections is perfect. A tiny camera positioned on the end of the riveting machine allows Kai to carefully examine each rivet, making sure to catch any abnormalities in the process.
I make sure that the drill doesn't get stuck or any mistakes happen. I have my different systems here. It can happen that something is stuck or that an error occurs.
It's a repetitive process, but Kai must remain vigilant to safeguard the lives of future passengers. Around the world, manufacturers and suppliers are putting the finishing touches on the components of the A380. But putting all the pieces together will be a logistical nightmare. Airbus's existing transport system, the custom-built mega-freighter called the Beluga, is too small to haul the A380 components to the assembly factory in Toulouse, France. So builders came up with a risky plan to haul millions of dollars of critical components by water and land. Airbus had a problem. They needed to move pieces for the largest passenger plane in the world from factories all over Europe to their final assembly plant in Toulouse, France. For smaller planes, they could use the Beluga, Airbus's distinctive custom-built transport plane. The Beluga's cargo hold measures 7 meters high, 7 meters wide, and 38 meters long. Big enough to swallow the fuselage, wings, and tail sections of Airbus passenger planes like the 150-seat A320. But when Airbus decided to build the massive A380, the sheer size of the parts overwhelmed even the Beluga. The Beluga is far too small to carry the A380's enormous triple-decker fuselage or its record-breaking wings. So to get their parts to the assembly plants, the company now had to move them by sea and over land, instead of a 2-hour ride in the belly of the Beluga. Parts for the A380 joined a days-long parade of specially outfitted ocean ships, river barges, and trucks. Keeping this massive system on schedule is the job of Surface Transport Coordinator Philippe Nedelec, who has to keep it all moving fast.
I like to say that I am a kind of conductor. I have to impose the tempo to everybody.
Wings and fuselage arrive by sea in the port city of Pauillac in Bordeaux. From there, it's 96 kilometers by barge down the Garonne River. It's a tricky bit of navigation to clear the historic Ponte Pierre bridge, a prized landmark built by Napoleon almost 200 years ago.
We have to cross a very old bridge. And at the beginning, the Bordeaux people were very afraid. What these Airbus people are going to do with our nice bridge.
To maneuver beneath the Pont de Pierre, Philippe and his team keep careful track of the tides and the weather. If they don't time their trip just right, if the water is too high or the currents too strong, they could collide with the bridge, destroying precious cargo and damaging a priceless piece of history as well. But waiting for the perfect moment isn't always an option.
Suppose we miss a call for weather condition or some other things, then the boat can miss a tide, so we can miss 6 hours, and this 6 hours you can miss 1 week, because we cannot start the convoy, the road convoy every day. It's not so easy. We cannot start when you want.
Every pass under the bridge is a potential disaster. This time, they make it through, but just barely. Next, it's a handoff to a fleet of trucks and their escorts. Now it's a slow crawl, 16 kilometers per hour for the last 250 kilometers of the journey.
You cannot leave these trucks alone, so you have some trucks for... It's very, very strange. People are very, very interested with that and very pleased. It's like a show, a permanent show, paid by Airbus.
So far, this roadshow has had an exotic appeal. But will they still be clapping when convoys like this grind through town once a week? Ultimately, that's the pace Airbus will have to keep if they're to meet their manufacturing targets. At last, the convoy arrives at its destination, the final assembly line, the nerve center of the entire operation. The final assembly line sits on the edge of Toulouse's Blagnac Airport. As with all A380 factories, this one is huge. 500 meters long by 250 meters wide and 15 stories tall. 32,000 tons of steel, enough to build 3 Eiffel Towers. It's in here that the massive plane finally begins to take shape, with the help of a gargantuan assembly structure known as a jig. According to Julien Pouillou, there's nothing else like it in the world.
We're standing in front of the biggest jig that is used in the world to assemble an aircraft. This is the Station 40.
Station 40 is where the fuselage, wings and tail all come together. The one-of-a-kind jig stands 5 stories tall, weighs 1,200 tons, and comes equipped with 4 elevators to carry workers to their stations. This is where theory becomes reality. As pieces made all over the world finally come together. If there's been any error, if the pieces don't measure up to spec, or if the joints don't come together just right, within millimeters, the huge passenger craft won't be fit for flying. The lives of future passengers depend on the steady hands of these craftspeople and engineers, working inside the mighty Station 40.
The challenge is for us to assemble those pieces together at the same time, because we have a lot of workers working in the same area at the same time, and they have to do all sorts of completely different tasks. One has to take care of the wings and one has to take care of the fuselage, and so they are not doing the same job, but they have to do it together.
Work on this plane now proceeds at an intense pace. It'll take 4 weeks to complete the assembly. Once the plane has been released from Station 40, it moves through a pair of 100-meter wide sliding doors and makes its way to the systems hall. Inside this gigantic space, 3 A380s can sit side by side comfortably, while technicians swarm over the superstructure, testing the electrical, hydraulic and plumbing systems that'll bring the dormant aircraft to life. Building just one A380 is a massive job, but for Airbus to survive, they're going to have to speed up production to a breakneck pace. Eventually the Station 40 team will have to crank out a defect-free plane every week. But before that can happen, the plane must be proven airworthy. Now all eyes are on the skies over southern France, as the gathered crowd wonders, will the A380 survive its maiden flight? At Blagnac Airport in Toulouse, 40,000 people anxiously scan the skies, searching for some sign of the A380. All flights in and out of the airport are put on hold. The skies over Toulouse are eerily quiet. Nearly 4 hours have passed since takeoff. If all goes as planned, the huge airliner should swing into view at any moment. But if there's a problem, the flight crew will quickly discover how well their training has prepared them for disaster. Much of that training took place using powerful computers, programmed to mimic the behavior of the A380. That's the theory anyway. In a simulator like this one, with a computational engine 500 times more powerful than a home video game console, photorealistic visuals help pilots to get a feel for the plane. Despite the A380's unprecedented size, Airbus engineers have tried to make it fly like any other airliner.
100 knots.
The task of testing the verisimilitude of the simulator experience rests on the shoulders of pilot Claude Holbeck.
I would say that it's exactly as a conventional aircraft. And it's quite amazing because this aircraft is so big and so heavy. This surprised most of people, and especially pilots.
One of the most important functions of simulators is to give pilots the chance to flirt with disaster.
Very simple, and one engine is shut off. This is the engine number 4, and look what is happening. The aircraft is just moving slowly on the right side.
It would take a lot more than an engine failure to knock this monster out of the sky. But test engineers are nothing if not imaginative, and they've loaded their simulators with more than 400 different catastrophe scenarios. Everything from a fire in the cargo hold to a devastating lightning strike. The exercises are useful, but no computer can simulate the awesome responsibility of shepherding 550 passengers through the stratosphere.
The challenge is to fly with many passengers. I think this is the greatest challenge, yes.
Outside, all eyes are on the sky. The weight is excruciating. Then, a glint of reflected light. At last, the mega plane sails into view. Eager reporters and photographers race to the edge of the tarmac to record this historic moment. A showy flyby excites the crowd. Makes a steep turn, lines up with the runway, begins final descent. Then, at long last, touchdown. Like astronauts returning from space, the pilots and the flight engineers greet the crowd. It's now one for the record books. If nothing else, the A380 is a public relations success. Journalists from around the world scramble to file their stories. Chief architect of the entire project, Charles Champion, is proud and relieved.
I think it was a great moment of emotion, and somehow we did it. You know, it's alive. It's alive.
They've proven that the plane can fly, but that may have been the easy part. At the time of the test flight, Airbus had 154 orders and still needed 96 more just to break even. To fill those orders, they must dramatically increase the speed of production and convince the world's airlines to pay nearly $300 million for each plane. But even while potential customers were lining up to drool over decor, and the engineering team was still basking in the afterglow of the successful first flight, Airbus surprised the industry when it unexpectedly announced a 6-month delay in the delivery of the first aircraft. Early customers who took the risk and put down deposits before the first plane had ever been built are not happy. Some analysts believe the plane is still heavier than Airbus promised, but Airbus insists that the delay is merely routine.
The real achievement will be when the customer says, "Great, this is what I expected, I love it, give me more."
If the last 40 years in the history of aviation is any guide, and more people fly further and more often, year after year, then Charles Champion's daring bet may well pay off, and the A380 just might become the flagship of commercial aviation. well into the 21st century.